So thanks very much for the opportunity to present you this update, which is mainly about the cooperation of different initiatives, all aiming into the direction of open architectures. So it's quite deliberately postulated by now that we need open architectures to make digitalization happen. And now with all the different approaches you have seen and you might have in mind, so the question is already now valid, so which one, please, would you like to prefer here in this case? So late last year we have been sitting together with Don Bartusek from ExxonMobil, the Open Group, the ZVEI, which is a German association of the electronic industry from the vendor side, so while NAMUR is the association from the user side, and have been discussing various initiatives and so how those might go synergetically together. So I would like to start with a couple of ideas, so why we need those new approaches to open architectures. You might not need any further motivation for this, but it was a little bit also fun to prepare it in that way. And then a brief overview about these three initiatives. So if we had Saudi Aramco on the table, it would have been very easy to also incorporate that here and also into the synergetic path forward for those approaches. Let me start with this. So for our NAMO General Assembly last year, I have done analysis of certain megatrends which have been in the agendas since 1995, which also represent somehow the interests of the industry. And there were some repetitive patterns to be seen here. One was, for example, that Fieldbus occurred repetitively and also that it's quite a time those topics reappear. So here, like 1996, the Fieldbus between vision and reality. So the Fieldbus is now for more than 20 years being introduced, and if you look at the current sales numbers, 420 milliampere analog compared to digital is still being on the path of being introduced, while Ethernet in the field, now this was also titled, is already in the space between vision and reality. Another topic which is very common is around asset management of field devices. Here it started also more than 20 years ago with intelligent actors, so better wealth diagnostics, etc. So this is also a topic which has not been reinvented now with big data analytics and comes back from every now and then, optimized maintenance strategies, etc. A very important topic, for example, also is around CAE systems and their coupling to automation systems. And for me, this is also a very decisive factor in the end, because if we talk about data being gold or oil for the 21st century, so this will really decide in the end also if you're talking about the trash of the 21st century or really the gold. Because if you do not know where our data come digitally from and can have a digital management of change, so we will not be able to have any machine learning, artificial intelligence, or anything else on top of that. A topic where there was no repetition anymore was process control with ERP systems. So this started in 1996, where it was around strong couplings of SAP and control systems. And so this stopped in the year 2000 with a talk about process control with SAP. So probably that talk was so convincing and that there needed not to be any further information. And also, so what is more at the heart of this talk today, architectures itself are not exactly new. For example, this is a picture from 1998 and 1996. Around there it was drawn as a cake, having a central database and then modularized around it, for example, that you can have batch systems, HMI systems and alarm systems from different vendors put together. Nowadays you would formulate this very differently with the platforms, etc. and apps, so but that was a first glance at that. And now the question is, why hasn't this been achieved? Because the ideas have been on the table now for 20 years, and let's say they have not really fulfilled their full business promises. So this is the formulation with the camera running. Yeah? And obviously there is a more disruptive change required if we really want to make progress. We cannot go from one local optimum to the next, then we will not have this big change and will not be able to come forward. And often, if you really try to do these things, you will come across problems which have to do that the platforms are lacking interfaces or that the interoperability is really a pain in realizing such projects. And therefore, there are these initiatives in place like NAMO Open Architecture, Materialization, open group to facilitate this, and then in the end to really make that happen more efficiently. Okay, let's start with the first one, NAMO open architecture. I actually plan to go about this very briefly, but I learned in the morning so that many of you are here for the first time, so I will go a little bit slower. This one starts really from the automation pyramid once more, where we have certain advantages and those we would like to keep. First of all, it's a proven and widely accepted structure. We have thousands and thousands of people who know this structure, and you cannot change this every now and then if it's accepted in the plants once. It provides highly available and mature systems, so the market is not overly huge for those systems, and therefore having achieved a certain degree of availability already is a benefit on its own. And last but not least, it supports sustainable operation with long life cycles. Because as it was pointed out in the first talk, each level has its own life cycle, being longer on the floor level with the plant starting, and it gets faster and faster and faster. And therefore this also provides a logical decoupling of those different life cycles, and at least in principle gives you a possibility and a guidance to cope with this. On the other hand, those systems are not open, and parallel data flows are being generated around it, which then also compromises the security which we have tried to introduce with this layered approach. New technologies are integrated slowly or not at all, for example, like Fieldbus, and the reason for this is then also that everything is highly availability critical and that you have no room for trial and error, and therefore the question comes up, will we lose track of modern technologies if we stick with this kind of architecture? And so kind of the intermediate answer which we found for this is to have a layer on top of it. So not to replace it entirely, but to have a layer in parallel which is able to communicate, to extract the data on a secure way, on an open way, and also to write back in a secure fashion. So an enhancement of the existing structures, flexible and ready for the utilization of 4.0 technologies. Also you can read from this basically that we have very strongly the installed base in mind. So it was said in the morning, so that when ExxonMobil now has the once in a lifetime opportunity to make a step change, to really change the automation infrastructure, we as BASF and many NAMO companies are already past this step. And we have exchanged the major dinosaurs already, and therefore we need also now to make best use of what we have and cannot only think about greenfield projects in this case. A little bit more detail how this looks like. So we're envisioning to have a core process control area, which is always depicted in gray with the sensors and actors which are able to do in-loop control. And we are having two monitoring optimization layers. So on the left-hand side, so also where you would have add-on sensors which are not critical for control, but more for monitoring, for maintenance purposes, etc. And also an open platform which is cross-plant spanning. Okay, enough for this. Then I would like to go into the modularization approach. This was in our General Assembly presented by ZVI, so I will take this part over here as well. Modularization, I'm not sure if this is a more European story. I have not heard it here too much apart from one talk which was 2 or 3 years ago. So modularization, what I particularly like about this approach is that it's not an automation approach for automation, but that we are here a trend follower for plant and process design. So this mainly comes from pharmaceutical areas, from fine chemicals, food and beverage and others who are very much relying on production and engineering with different units and which want to gain flexibility, time to market improvements, resource efficiency by plugging more units together instead of having large integrated plant designs, which also is followed by an integrated process control design. And so this is being driven equally then by the plant design itself, by the process design, and automation somehow needs to follow. If you have those skid units, each of those has a PLC on it that you also support it from an automation point of view to plug it together. So we have the automation portion, and this is then subdivided into different topics like process control, safety security, alarm management, HMI, and maintenance diagnostics. And so the engineering process here is that on top you have a process control level. That would be classically a DCS, but must not be a DCS in the end. So it can be a system which orchestrates the different units. And on the left-hand side, so laser pointer's not working. So you see, if you have a module, you upload it to your engineering system and can then bring it live on the service bus, which connects all these modules. Maybe to make this a little bit more tangible, what has been achieved is a standardization of the HMI in the form of an automation ML. So there has been compromise on a standard between DCS vendors and package unit vendors on how an HMI for the package unit is described. And instead of rebuilding all those pipes, vessels, etc., which come with this unit in the DCS, then you upload this automation ML. You only need to assign the pixel space, and then it will automatically create the HMI with the information coming out of the unit. So it's in the end then also open, it's vendor independent and based on existing standards. And this is intended to go on now for alarm systems, etc. And so the timeline is that this HMI integration has been designed, services, diagnostics, alarms, and safety to follow. This is also an IEC new work item proposal, so this is going into the direction of internationalization, which then in the end also makes this usable for initiatives like the Open Process Automation Forum. And for that part, I would like to hand over to Don.
Gosh, what an exciting time to be working in control and automation. I'm really pumped up about this. So I'm going to flash by. I have 4 slides on open process automation that were presented in Germany in November. I'm not going to use them. This audience is better prepared, so I don't need to go through the background. And I'm going to tell the essence of what the story is. So to me, the story that I'd like to tell, and you're going to see Michael's going to close it out with the same message, is this is about finding common ground of user needs and coalescing into a critical mass of force for constructive change. So that's what this message is all about. And let me just flash through the slides again, in the spirit of full disclosure, to see what we talked about at the Nemours General Assembly. So we've presented this information at ARC Forum a couple of times. I'm just going to flash by it. This is the reference architecture slide that Dave talked about. I'm going to come back to this to make my points. This is background on how ExxonMobil got here and how the Open Process Automation Forum came to be. And this is one visualization of our plan and schedule and timeline. But let me go back to the reference architecture slide and make a couple of points. So Michael has introduced what Nemours Open Architecture is and also what MTP modular type package. The essence of the open process automation idea is the existence of this highly distributable device we call the distributed control node that is envisioned as a combination of a configurable I/O module with the possibility of doing some computations, and in my mind is basic regulatory control. Now the market, I believe, will determine whether that's a single channel device or multiple channels, whether it's I/O only or how much compute you can afford to deploy in that footprint. An industry standard communications bus that allows a high degree of interoperability and communication standardization, and the real-time advanced control platform that Dave DeBarry already highlighted. Again, and what's envisioned but not visualized here is security is designed in, not bolted on. Now, the Nemours Open Architecture idea, functionally in my mind, is something that at least some of us operating companies are already doing today in some form or another. So a lot of the types of applications that Michael was talking about are ones that we actually deliver at level 3 in the Purdue model today. So to map that to open process automation reference architecture, the envisionment of this real-time advanced control platform really is a collapsing of the level 1 through level 3 in the classic Purdue model. Again, where the end user can get the availability he or she wants by the characteristics of that platform. And the ability to interface to new categories of sensors is envisioned in this model by things like the wireless gateways, et cetera, the machinery monitoring applications. So point number one, the functional requirements of the Nemours open architecture idea, perfectly legitimate and valuable business ideas, we believe can be supported and delivered and implemented in this type of an architecture, where you either do it on-premise in something that looks like a data center in your existing enterprise systems, or possibly by cloud delivery. The second idea on the module type package, we envision that its instantiation in this reference architecture is really these gateway devices that are depicted here as the interfaces between, or the interfaces to existing equipment, existing systems. So MTP in its essence is really middleware that allows an abstraction of vendor-specific devices, and from the top level view of the asset owner, it allows you to abstract and generalize those individual devices. The comment that we've made, and I guess this is, I think, a great example of how science is supposed to work. So Michael and I, BASF and Nemours, we've been talking about this idea now probably about a year and a half, and I think we're coming to meetings of the minds of what we have. So it's not like these ideas are in conflict. It's more about how far out in the time horizon do you want to shoot, okay? So in essence, I would say my message is that I think we are very well aligned in terms of the goals and the ultimate objectives between open process automation idea, the Nemours open architecture idea, and the MTP initiative. The difference is perhaps the trajectory to the ultimate solution, and that's kind of where we are as a peer group debating ideas. So with that, we at the meeting we had in when was it, Michael? November? We committed to do the memorandum of understanding. When did we do that? When did we agree that the memorandum of understanding for collaborations between Nemours and open process automation? Thanks, Ed. Thanks, Ed. Yeah. So we agreed to collaborate. Okay, and we have work underway, a document in the form of a memorandum of understanding, so that the Open Process Automation Forum can share documents and work products in process with Nemours and vice versa. So that's the message I want to leave you with. This is not, and Michael is going to reinforce this in his closing remarks, these are not conflicting initiatives. We think it's really finding that common ground of end user needs, end user wants, coalescing to a critical mass for change, for constructive change. And that's the message that I wanted to leave with this audience today. Okay, so Michael, back to you.
Okay, a couple of pictures to underline this message. So, as a summary of these initiatives in the end, so we had here Nemours open architecture with the strong focus on the installed base coming from Nemours. And also from the core idea, we never had the intention here to specify a solution, but this was always rather meant as specifying a requirement in terms of architecture, and so we are more than happy if the solution is specified, which is usable and fulfills all those needs. The MTP modularization idea is mainly focused on the engineering phase, I would say, on the seamless unit integration and minimizing the engineering efforts and speeding up plant design. And open process automation, as you know, is really at the core of the system, establishing open systems and standards at all levels to be able to buy best-in-class solutions there. And you now look at the holistic picture through the eyes of this open process automation idea. In the end, if we have a real-time service bus, for example, with OPC UA, and a real-time computing platform in place. So what we need at the core is really a connectivity between those, which is vendor independent, and this can be served by the MTP. by one MTP, maybe you need multiple for if it's a complex DCS, but in the end, so that can be the middleware to connect a complete, whole, full-blown DCS then to the real-time service bus, and to realize the monitoring and optimization applications within the real-time computing platform, because it's only a subset. So there's nothing to be added to this one. It's a subset and a smaller profile of the overall real-time computing platform. And if you follow this trajectory, what modularization is about is already reducing the functionalities of a DCS, because you want to move things like HMI, batch control, alarms, etc. You want to move this. There it was called a process control layer. It was intentionally not called a DCS at the times back when modularization was first introduced, because it could be something different, and it could perfectly be another subset of the real-time computing platform, larger than monitoring optimization, still completely including it, but being realized on this platform. And then the final step of this trajectory would be also to have control either in the real-time platform or then in the distributed nodes, that also regulatory control is executed here as a third step. And naturally, there will be several years of coexistence of those solutions, on the one hand side because of installed solutions, also with developments already in place, so which need to earn their business cases. But there's, as Don said, there is no conflict. It's a trajectory moving from the full-blown proprietary system, reducing functionalities, moving then into an open platform. Okay, a lot of this has also been said already. So in April in London, we intend to move on then on the basis of the Memorandum of Understanding, which is currently with the lawyers. They found some issues in it, so that we can move on to discuss technically what this means. And as a summary, so the message I would like to leave you with is that we really need to cooperate on this. So NAMUR represents like 130 end users being organized, which more work on this requirement level, because they might not have the resources to go deep into the technical aspects like an open group does, and that we can join forces here really well to give an overall picture to the industry. So thank you very much.